So in the first part, we will be looking at the anatomy, starting with the myosin and the actin. Both of these are filaments. Then we go to the tropomyosin, which is located on the actin filament, the troponin complex, which is also located on the actin filament, and then the calcium on the troponin complex. Later in the muscle contraction, we will see how the calcium plays a part in helping the process of contraction. Then we go on to see the neuromuscular junction. So you can see the axon and then the myelin sheath surrounding it. So the action potential will pass through the axon, and then it'll go through the vesicles that contain acetylcholine, and then the action potential will pass from the motor neuron to the muscle fiber. This is where the motor neuron and the muscle fiber make contact and transmit chemical signals. Then we look at the sarcoplasmic reticulum. This is located around the muscle fibrils, and it releases calcium for muscle contraction and then reabsorbs it when the muscle needs to relax. Then we look at part 2, which is muscle contraction. So it all starts when the brain sends a signal and an action potential has to pass through the motor neuron. And this is where the neuromuscular junction comes in. So the motor neuron makes contact with a muscle fiber, passes the action potential, and then acetylcholine is released from the vesicles, and then they attach to the receptors on the muscle fiber. And then an action potential is allowed to pass through along the surface of the muscle fiber, and then it goes to the transverse tubule where the sarcoplasmic reticulum is located, and then the sarcoplasmic reticulum releases calcium ions. So then the calcium ions attach to the troponin, as we saw earlier in the anatomy segment, and calcium ions latch onto the troponin. It causes the troponin to remove the blocking action of the tropomyosin, so therefore making it an active site and making it become exposed. So after this happens, the myosin filament forms a cross bridge with actin, and then this results in contraction because the actin pulls filaments toward the middle of the sarcomere. And then the head of the myosin bends and releases ATP, and this is a continual cycle. And of course, muscle contraction occurs because the sarcomere is being shortened and then relaxing and then shortened again back to its original length. And the way that the sarcomere relaxes, or the muscle relaxes, is after all the acetylcholine is broken down, the action potential stops along the muscle fibers, and then the sarcoplasmic reticulum stops producing calcium ions, and it reabsorbs all the calcium ions that it released earlier. And then, without the calcium, there is no movement of troponin or tropomyosin, therefore none of the other steps can occur. Segment rigor mortis. So rigor mortis is when the muscles stay contracted for hours after death. And this is caused because the whole body shuts down, the respiration system, the digestive system. So when the respiration system shuts down, there is a lack of ATP, and this causes the myosin and the actin bridge to remain intact. Therefore, the myosin isn't free for the next contraction to occur. So then the muscles just remain contracted as if the person were still alive. And this is why you see the muscles are locked up and halted to a pause.